and share my screen. And so, yeah, the chat's open down there. Let me move this out of the way. Let me go here. A couple general announcements. Today we're going to be looking at combinations and probability. Oh, you know what? I'm going to add something to the list of stuff. There's going to be a quiz on Thursday just on counting, permutations, and a tiny bit of combinations. We will not have class on Thursday. I am the college representative to the Faculty Council of Community Colleges, which is a SUNY organization, and I have to go every semester to, it's like a conference where they discuss, different things that are coming to the campuses from the state and give feedback from the campuses to the state. It's usually held at a different campus every meeting, but this one and the one in the spring are virtual. But even so, because it's an all-day meeting, I will be unavailable for classes on Thursday. And so I will also not have an office hour Thursday or Friday. My math lab 6, which was on the counting principle, and 7, which is on permutations, is due today. No, I'm sorry, I take that back, or due on Friday. The assignment 8, which is on combinations, will be due on Monday. The project is due today. And again, we'll have that quiz on the counting principle, permutations, and a little bit of combinations on Thursday, again, because we're not having class. It'll just be that quiz is in my labs, and there will be a folder in Blackboard for you to submit your work. Please submit your work in the folder because I'm grading them in that folder. So even if you do it in my labs, if there's nothing submitted in there, there's a chance it might not be graded. So please make sure you do that. Before we get started, does anybody have questions on anything that we've been working on? Does anybody have questions on any of the homework or anything?
I have a question on the project.
Yes, ma'am.
I think what I did is I may have overcomplicated my survey.
Yeah? What did you ask?
Well, I did questions on like binge watching TV. And so my questions were, do you binge watch TV? What type of shows do you like? And what carrier do you like Hulu, Amazon? And I thought that it would be simple enough. However, when I kind of put in my stuff into a grid yesterday, I was like, how am I going to make this into a diagram? Like, what am I doing?
What I'm guessing is when you asked what type of shows, you got all sorts of answers.
Some were relatively, the same. Like I kind of went and color coded them yesterday, and I had like a lot of crime, a lot of comedy, a lot of reality. But then I have a couple of off ones,
But the problem is because you've got so many different answers, you can't really put that question in one loop. So what you need to do is focus on just one of those types.
Okay.
So which of those types do you like the best?
Okay.
And I'm asking you, which is your favorite?
Oh, okay. I would think crime and reality seem to be like the most, or comedy seem like to be the most categories that I have.
So make one circle, focus your question on, do you binge watch crime?
Okay.
And either it's yes crime or no crime, or do you binge watch comedy? Or you can maybe, if you want to group them together, do you binge watch either crime or comedy and have that, and then people who don't outside. And then in terms of carrier, pick one carrier. Is this your carrier? And either they're in that loop or they're out of that loop.
Okay.
It was because you didn't have yes, no type categorical questions, yes, no. You've got a plethora of answers, so narrow them down. Like in that example that I went through in class, and I said, what's your age? It's like, oh my God, people could be any age. So I narrowed it down and said, are you over this age or under this age? Narrow it down so that you can put it in a loop. Does that make sense, hon?
It does, yes.
Okay. And does it make it uncomplicated?
It does, yes.
Good.
Thank you. Thank
All
you
right.
very much.
Anybody else have any other questions?
Yeah, if you don't know how to like draw the Venn diagram in like Word.
Oh my God, don't draw it in Word. It's a pain in the ass.
Right.
Draw it by hand.
It
Write it by
truly,
hand.
it truly is. I mean, I was able to like cut and paste and copy the circles,
Oh
but
my
then
God, I'm
I
sorry.
can't figure out how to
I
like
was trying
write.
to do, yeah, I was
it.
trying to do that too. I was
Sorry.
trying to cut and paste, but everything keep moving with the circle.
Yeah, no, I'm so sorry. I thought I said, don't worry about typing it. Draw it by hand and put it in your picture in the Dropbox. And you can,
Oh, all right.
you don't have to type any of it. It can all be handwritten. I hate typing. So, no, the only people I would require typing of is if your penmanship is totally illegible. If you can't read your own writing, you can type it. But no, draw it by hand. There's absolutely no need to type that. I only typed it because I actually I didn't really when I first made that example, I didn't really have something that allowed me to upload handwritten documents. And so that's why I typed it. But no, it took me a very long time to type that. It took me years of teaching math to figure out how to use X boxes and all of that. You don't have to type it. Do it by hand.
Okay.
Okay.
I already did like the survey part. It's just the Venn diagrams. So I'll draw those on paper.
Draw those. And I think you can, you know, you can submit your Word document, or your Google Docs or whatever. You can submit the typed one in the Dropbox and then also submit the pictures in the Dropbox. That I think it allows you to do both, so that shouldn't be a problem. Okay.
Okay. All right. Thank you.
All right. Any other questions?
Yeah,
go ahead.
I have one for the project.
Sure.
What's it called? When I went to submit it, I forgot to submit a part of it, and then when I submitted the pictures, it cut off part of the Venn diagrams.
Uh-huh.
So was it all right if I emailed the project to you instead? Because I couldn't figure out how to resend it through Blackboard.
Okay, let me, yeah, I guess it'll be fine. I was gonna say, let me double check and make sure it's set so that, I thought I had set it so you could submit it twice because some people had done it early and needed clarification. So you might be able to resubmit it. If you can't, then just email it to me.
All right, I already did email it to you.
Okay, all right. When did you email it to me?
Like Sunday night.
Okay, then I think I might have, dog-eared it. What I'm trying to do is when somebody submits something like that to me digitally, I try to respond to you. Did I respond to you? And forward it to myself again with like flagging it that it's important so that it doesn't get lost. But hopefully I'll find it.
All right.
Let me real quick. I have this list, pencil and paper list of things I have to make sure I pay attention to. And so let me, who am I talking to?
Colton.
Colton. I'm just putting Colton project on the list.
All
So
right.
I remember to look for it. Okay.
All right. Thank you.
All right. Anybody else? If not, let's start looking at more permutations and combinations. So I'm going to minimize. Whoops, I think I'm going to minimize. Maybe I'm not going to minimize. And I'm going to add a page. And I guess I'm going to ask people to remind me from last class what a permutation is. Anybody help me out remembering what a permutation is? Arrangements.
Listen objects, no repeats, and then the order matters.
Distinct objects. No repeats. Order matters. And then we had NPR, which would be arrangements of R objects chosen from N objects. And I should change that word arrangements to permutations, I'm sorry. We said NPN is N factorial. We said that NPR is N factorial over N minus R factorial, or the first R factors of N factorial. And we said that anything permutation 0 is 1. And we looked at some examples. We're going to start today looking at one specific type of permutation that's a little bit different, and those are permutations if there's some repeat. How do you spell there? And to do this, I'd like to start by looking at a couple of examples. I want to know how many ways you can arrange the letters in the word dog. And so, first of all, there's 3 letters, and we want to use all 3 of them. It's unspoken, but it's implied. And so there's 3 letters. We want to pick 3. So that would be 3 factorial, or 3 times 2 times 1, or 6 ways. And so if I ask you to list them, I'll do the hard one. D, O, G. Can anybody think of another arrangement of the letters in the word dog?
ODG.
O, D, G. Any others?
GOD.
G, O, D. Any others? Any that's
Never mind.
any others that start with D?
GO.
Yeah. Any others that start with O?
GD.
And any others that start with G?
DO.
DO. And at some point in time, I like using the counting principle or my permutations to figure out how many there are, just like we did when we were listing some sets, because I know I've got them all. And so life is good. Everybody comfortable with that type of question? I want to know what if I ask you to arrange the letters in the word all, A-L-L. And again, I'll do the hard one, A-L-L. Is there another one where we can arrange those letters?
LLA,
L-L-A.
LAL,
Are there any others? No. And so do you notice that there are fewer if some repeat, if some letters are the same? But it's still, well, it's not really a permutation because the objects aren't quite all the different. You know, there is that repetition, that one letter that is the same. Because order matters, it's going to fall under the heading of permutations. And so if I look for the number of permutations of n objects, if R are the same, now I'm feeling remiss. I said R without my best pirate imitation. R are the same. Never mind. S are the same. T are the same. And I'm going to put dot, 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 is given by and first of all, are we all in agreement that it is a smaller number when some of them are the same? And so if they were all different, it would be n factorial. And what's going to happen, the way we're going to make that number smaller is we're going to divide by a factorial for each thing that repeats. So it'll be n factorial over r factorial, s factorial, t factorial. And there could be more if there are more letters that repeat. And so now I'm looking at this and I'm thinking that this is probably about as clear as mud. So let's go through and let's look at that example, ALL. In ALL, we had 3 letters total. And there are 2 L's, and so 2 letters repeat. So the permutations would be 3 factorial divided by 2 factorial. 3 factorial, again, being my 3 times 2 times 1. 2 factorial just being 2 times 1. And so that turns out to be the number 3, which was the repetitions that we got. Does that example make sense, folks?
Yep.
So then what's up with all of that S and T and all of that? I'm going to turn the page if everybody's all right, because I think this page is getting long. And I'm going to look at the word I want, arrangements of all the letters in the word MISSISSIPPI. So what's N? What's the total number of letters in that word? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11.
Mm-hmm.
What's R? Is there a letter that repeats?
Yes.
What? What's a letter that repeats?
I.
I. And
S.
how many I's are there?
There are 4.
4. Another letter that repeats is S. How many letters are there?
4.
And is there any other letters that repeat?
P.
P. And how many P's are there?
2.
2. And so the total number of permutations would be 11 factorial over, we have to have a separate factorial for each separate item that repeats. So we'll have it over 4 factorial, 4 factorial, 2 factorial. We need a separate factor in that denominator for each letter that repeats. Now, I'm going to be a glutton by punishment and figure this out first time by hand, seeing how much you folks can remember manipulations of fractions from when you were younger. So we've got in the numerator 11, 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. In the denominator, that first factorial is 4, 3, 2, 1. Then we have another one, 4, 3, 2, 1. Then we have another 1, 2, 1. Does everybody remember you can cancel out common factors? So I can divide out that 4, 3, 2, 1. And then let's see, 3 times 2 would cancel out 6, because 3 times 2 is 6. And 4 times 2 would cancel out 8. So I'm left with 11 times 10 times 9 times 7 times 5. And is there anybody who'd like to please multiply that out for me and tell me how many ways we can arrange the letters in Mississippi? Is anybody else getting 34,650?
Yeah.
Now, that's by hand, sort of. And now if I look at doing it by calculator, could everybody with their calculator, we found where their factorial key is, take 11 factorial and divide it by 4 factorial, 4 factorial, 2 factorial, and tell me what you get. Are you folks getting the same answer? Or something different? When I typed that in, I don't know if you can see my calculator display or not, to make it look just like what I have written, I'm getting some crazy number like 798333600. Is that the same?
Nope.
No, I did something wrong, and I did it on purpose. Is this the way you guys typed it in? Is this what you guys got, or did anybody do anything different?
Mm.
I'm gonna put parentheses around
You
the
have
bottom
to
one.
put parentheses around the denominator. What we did this time, which was totally wrong, was if you typed it in as 11 factorial divided by 4 factorial, 4 factorial, 2 factorial, the only one that's divided is that first one, and then it multiplied by the other. And so when you enter a fraction like this in your calculator, it's really important that you remember that while when we do it by hand, we kind of treat it as if there's parentheses there, because there's invisible parentheses there. The scientific calculator cannot see those invisible parentheses. And so you have to type that in as 11 factorial divided by, and then you have to open parentheses, 4 factorial, 4 factorial, 2 factorial. And if you do it that way, you should get the same results. And so when you're putting in complicated fractions in your calculator, make sure that you make those parentheses around the denominator or the numerator. If there's computation going on in the denominator or numerator, make sure you type them in. Right?
Professor?
Yeah.
I don't mean to interrupt, but to totally interrupt, I just tried to turn the project in and I accidentally, for the document that we had to like type our responses and stuff, I accidentally submitted the document that you sent us with the instructions. So how do I like now submit my actual work?
You should be able to still submit more in the Dropbox. You can submit more than one document.
Yeah, but when I click on it, it just says review submission. It doesn't let me like get back to the page where I can actually.
Okay, not in the middle of class, but after class, I'll make an adjustment so that everybody can submit twice in case that happens to anybody else. And then
All
you
right,
will be able
thank
to
you. Sorry about
resubmit.
that.
Okay, no worries. So let's look at one more example. Let's look at the word engineer. And so in the word engineer, how many letters are there total?
Oh, I keep on getting arrow on my calculator.
Oh, that's no good. Can you please show me your calculator? Oh, you don't have your camera on, hon.
Oh, awesome.
Can you show me your calculator and show me what you typed in? Can you call back what you typed in?
Yeah,
Did you put parentheses around the denominator?
yeah.
You've got the dreaded Casio. And the only reason it's dreaded is because I'm not that familiar with it.
Can you see it?
Yes. Now hit enter. Syntax error. Try putting in multiplication signs between the 4 factorial, the 4 factorial, and the 2 factorial.
Instead of the computation.
Type 11 factorial
Yeah.
divided by parentheses
Yeah.
4 factorial times 4 factorial times 2 factorial, and then close your parentheses.
Oh, yeah, I got it.
Okay. All right. I'm sorry it took me a minute.
All right, thanks.
I'm using Texas Instruments, and Texas Instruments doesn't require that I put that extra in, but some, I guess yours does. So better?
Thank you.
Okay. And before I go back to, well, I'm going back to screen share. Did anybody else have a problem with that one? Or are we all good?
Nope.
Okay, so then engineer. When I look at the word engineer, how many letters are there altogether?
8.
8. Oh my, that was a slow motion move. 8. What letters repeat?
N.
N. And how many letters are, how many N's are there?
There's 2.
Any other letter repeat?
E.
And how many E's are there?
3.
Anything else repeat?
Nope.
No. So this is going to be 8 factorial over 2 factorial, 3 factorial. And so tell me what you get when you divide that out. Anybody getting an answer?
I got 3,360.
Anybody else also get 3,360? Everybody else also get 3,360? That's what I got also. Remember when you type it in to put those parentheses around there, and Christina, remember to put that multiplication sign in the middle.
Yeah, that's what I'm trying to do.
Yeah, I also got that.
Okay, good.
Yeah, I got that too.
Okay, good.
Yeah, I got it.
All right. Then if we're all good with that, that's it for permutations. So the next thing that we want to look at, is everybody okay if I turn the page?
Yep.
Next thing we want to look at are combinations. And combinations are going to be arrangements of, they have to be distinct objects. With combinations, I have no repeats. But what's different with combinations is that order does not matter. And so, just like with repeats, we have that idea that if order does not, with repeats, we said that there's a smaller number than with permutations. With combinations, if order does not matter, does it make sense that it's a smaller number? DOG, GOD, they'd be viewed the same because order does not matter. Kind of like when we look at the listing the elements in the set, we said that order does not matter. And so when I look at combinations, because it's a smaller number, let's start with an example. Let's say I have a class, and in my class I have 22 students. How many ways can I select 3 of them to work together on a project? On a problem, pardon me, not a project. In last class, we looked at a somewhat similar example, but we were looking at 3 people to work on 3 totally different problems. And we had said that if the problems were totally different, order mattered because it makes a difference to you whether you have the hard problem or the easy problem. Over here, if we're working together, does everybody see that order does not matter? Working together, if I work with you, it's no different than when you work with me. And so because they're working together, this is going to be a combination. And when we look at combinations, we're going to have NCR is going to be the number of combinations of our objects chosen from N. And I'm going to look at the definition of a combination in 2 different ways. Back in ancient times when we used to do things by hand, NCR was defined as NPR over R factorial. So using that definition, we'd have 22 combination 3. So that would be 22 permutation 3 over 3 factorial. And 22 permutation 3 would be the first 3 factors of 22 factorial divided by 3 factorial. And so I'm going to do this my little kid by hand way. And so when I take 22 times 7 times 10, I get 1540. Blitzer defines it a little bit differently. Blitzer says, what?
It's your echo.
I'm sorry. Blitzer defines it a little bit differently. He says that NCR is where we had said NPR over R factorial. NPR he defined as N factorial over N minus R factorial. And then he divides that by R factorial. And so if I look at this, that would be 22 factorial over 22 minus 3 factorial times 3 factorial. And if I look at that, 22 factorial would be the 22 times the 20 times the 21 times the 19 all the way down to 1. 22 minus 3 is 19, so that would be the 19 all the way down to 1. And then 3 factorial is 3, 2, 1. And if I cancel 19 down, see, it gives me the same expression. So it's just another way of writing that same thing out. Again, as a rule, I don't use this definition personally too terribly much, but if you're going to use the Help Me Solve It in my lab's math, they're going to pull out that definition. But I'm guessing that most of you, when it comes to something like 22 combination 3, would rather just use your calculator. And so if your calculator does factorials and permutations, it should do combinations. If you're using a calculator like mine, it's going to be in the probability menu, and you can arrow over the combination function, NCR, If you're using a graphing calculator, Texas Instruments graphing calculator, you're going to press the math menu, arrow over to the probability menu, and you should see a choice for NCR. If you're using a different brand of calculator, look at all of your keys. Above one of the keys, there should be a second or a shift function in a different color, NCR. Could everybody with your calculator just type in 22 NCR, however you get to that function, and then 3, and make sure that you get that same number we had before, which was the 1540. And I have to apologize. I just realized that I made a slight mistake when I opened everything that I thought I needed for class today. I forgot to open a page of the textbook, so you're going to have to bear with me in a couple of minutes while I go do that. With your personal calculators, doing 22 combination 3, is everybody getting that 1540?
Wait, where's the combination? Fine.
Is this Tina?
Yeah.
Where did you find the permutation?
It was over the x to the power of -1.
Okay,
It was
look at all of your other buttons. There should be a combination over one of the other buttons. I don't know which because I'm not that familiar with your brand of calculator, but there should be one there.
Oh yeah, I see it. I see it. NCR. Okay, all right, I got it. I got it.
Everybody else get it? If so, I'd like to ask everybody to look at a few combinations for me. Oh, I apologize. Oh, I'm a bad person. There's one exception I forgot to mention. Any number combination 0 will always be 1. Again, going on the idea that anytime I try to choose nothing, there's only one way of choosing nothing. And so now I'd like to show you something that, and again, it was probably more of a significant shortcut when we were doing things by hand than doing things by calculator. But I'd like everybody to figure out some combinations, let's say of 6 for me. 6 combination 0, 6 combination 1, 6 combination 2, 6 combination 3, 6 combination 4, 6 combination 5, and 6 combination 6. Those would be all of my different combinations of the 6. And I'm going to ask you folks to take a minute and find those values and write them down for me. While you do that, I'm going to go through and open that virtual textbook that I forgot to open. Everybody have them all written down?
No, not yet.
Oh, do you know what they are? Do you need to see them or can you?
Yeah, just
Okay, so you need to see them or are you good?
I'm almost done. Sorry.
Don't take them away.
I'm good.
It's 60, 61, 62, 63.
Go all the way to 6.
I don't even know. I don't even know what I'm doing.
So I'm going to real quick. But this book's going really slow. I'll go back and hopefully it'll be there when we're done. Okay. Using your calculators or doing it by hand. I'll do the hard one. We already said anything combination 0 is equal to the number 1. Did anybody get an answer for 6 combination 1?
6.
6, beautiful. Did anybody get an answer for 6 combination 2?
15.
Beautiful. Did anybody get an answer for 6 combination 3?
20.
Did anybody get an answer for 6 combination 4?
15.
Beautiful. 6 combination 5
6.
and 6 combination 6.
1.
1. Huh. Does anybody notice a different, an interesting, pardon me, pattern in that list?
Yeah.
You notice that they pair up. They're the same answers. They repeat. And if I try to make rhyme or reason out of the ones that repeat, do you see how 0 is the same as 6 and 0 plus 6 is 6? You see that 1 is the same as 5 and 1 plus 5 adds to 6. 2 is the same as 4. 2 plus 4 add to 6.
Yeah.
And so what's going to always happen is if I have n combination r, it's always going to be the same as n combination n minus r. So that if these two numbers add to the first number, those combinations should be the same. So when would that be useful? Let's say, for example, I asked a question on a quiz that asked for something like 100 combination 98, and you didn't have your calculator with you, but you had to figure it out. Would you really want to figure out 98 factorial in that denominator? I don't think so. But using this, that'll be the same as 100 combination. When I take 100 minus 98, what do I get? 2. And 100 combination 2, that's not bad. In my denominator, I have 2 factorial. In my numerator, I have 2 factors starting with 100. And that wouldn't be too bad to multiply out by hand at all. And so do you see how that interchange can sometimes make your life easier?
I don't know what's going on.
Okay.
I'm sorry.
Yeah, give me a big number.
Thank you, Gina.
Give you a big number. I don't know what's going on with the little numbers.
Well, this would only be useful if you had larger. So let's say I wanted to find 10 combination 8. And I'm not doing it with a calculator.
Okay.
Without a calculator, I would have to go 10 all the way down to 3 over 8 all the way down to 1 and work it out. And if I were doing that by hand, do you realize that would kind of be, oh, this is not a nice way to phrase it, but a pain in the ass? It would be a lot of work.
Okay, sure, yeah.
So this shortcut says that's the same as 10 combination. What's 10 minus 8?
Oh, 2.
2.
Okay.
And 10 combination 2, wouldn't that be much easier to find? If I were doing without a calculator. And so it's just a shortcut. It's not anything major. I'm not going to assess you on it. I'm just saying that, you know.
So, wait a minute, just so I can process it. So 10 combination 2 is 10 minus 8? What?
No, 10 combination 2 gives you the same answer as 10 combination 8.
Okay, so where'd the 9 come from?
If I were to try to figure out a combination by hand, we said that 10 combination 2 is 10 permutation 2 divided by 2 factorial. So 2 factorial, 2 times 1, 10 permutation 2 means I've got 2 factors starting with 10. Okay, if that's not a happy thought, when you do your combinations and permutations, will you always be using a calculator?
Yes, today I will go and get batteries because I'm lost. I don't know what's going on.
Okay, last class when we defined NPR, we said it was n factorial over n minus r factorial, which gives me the first n factors. I'm sorry, the first r factors of n factorial. So if I wanted something like, oh, let's say 7p4, that would be like if I had to race a group of 7 people and I wanted to pick 4 in order matter. We'd be picking 4, so we have 4 places. We'll have 7, then 6, then 5, then 4.
Mm-hmm. Mm-hmm.
Okay, and so what I was doing above was if I had 10p2, it means I'm picking 2 from 10, so I'll have 10 times 9.
Oh, okay, I get that now. Okay.
Okay, and so if I'm looking at 10c8, that would be 10p8 over 8 factorial. And if I were to do that out, I'd have 8 numbers top and bottom, which is a royal pain to multiply.
Okay.
Instead, I can do 10c2, which would be 10p2 over 2 factorial. So on the top, I have 2 factors starting with 10. On the bottom, I have 2 factorial. And it's just a shortcut. It's just a shorter way of writing it. We're just saying that those two should be the same.
Okay.
Better?
Yes.
Okay.
Yes.
Everybody else better. And again, it's a shortcut. If it doesn't come to mind, you don't have to use it if you're using a calculator to figure out all your permutations and combinations. But if you're doing it by hand, 10 combination 8 is a lot more work than doing 10 combination 2, so it's a shortcut.
Mm-hmm.
But what I was looking at the book for is because with these, when we start applying them to probability, I want to look at the book and we're going to just decide with different questions if it's a permutation or a combination or neither, the counting principle. And some of them are going to be a combination of them. Oh, can I give you my bad math joke?
Mm-hmm. Sure.
Have any of you ever used the combination lock?
Yes.
Yes. When you do a combination lock, when you put your numbers in and you're turning the dial or whatever, does the order of the numbers matter?
Yes.
Yes. So
Mhm.
shouldn't they be called permutation locks and not combination locks? I'm sorry, it's just a math person thing. Okay. Over a couple pages. And again, if you don't have a textbook, don't worry because these will be in the recording for today. I apologize, I should have downloaded these pages as PDFs and then I could have inserted them in the notes. I didn't think of that until just now. Usually in an in-class test when I'm looking in an on-campus class, wow, I just tangled my words up. In an on-campus class, when I pull up examples like this, I usually just balance the textbook on the document camera. So I'm going to make these look a little bit larger. that big enough for you folks to see? I have no idea what I just did. There we go. This is supposed to slide. Why is my slider not sliding? Okay. Oh, it did slide a little bit. All right, let's look at a couple of these in terms of whether they'd be permutations or combinations, and try to kind of set up the combinations and then have you guys figure it out. So I want to look at number 35. And so question number 35 says, to win at Lotto in the state of Florida, one must correctly select 6 numbers from a combination of 53 numbers 1 through 53. Have any of you ever played Lotto?
No.
No? Okay, when you play the lottery, you know, you can fill in that little scan card with your numbers, or, you know, the numbers pop out like ping pong balls pop up when they choose the winner. And when all is said and done, it doesn't matter the order in which the numbers came. You just have to have those numbers. Your numbers have to match. And so it says the order in which the selection is made does not matter. Since the order does not matter, would that be a permutation or a combination?
A combination?
Combination. And so when I fill in that combination, how many are there to choose from?
53.
53. And how many of them are we choosing?
6.
6. And so with your calculator, can everybody, or by hand if you're a glutton for punishment, could everybody take 53 combination 6? And what type of number are you getting?
An 8-digit number.
Yep. So what is that? 22,957,480?
Yeah.
A lot. There's a lot of different ways that that can happen. And so that's why they say you're more likely to get struck by lightning than win the lottery. There's you know, one of those 22 million would be the winner. Let's look at question number 37. 37 says, how many ways can a committee, all right, serving on a committee, if I'm on a committee with you, is that any different than you being on a committee with me?
No.
No. So in my mind, committees are combinations. Another thing that almost always turns out to be a combination is if we're looking at cards. Committees are combination, cards are combinations. And to help me remember that, any of you guys ever watched Sesame Street? Makes me think of the song, C is for cookie, C is for committee, C is for cards, C is for combination. I don't know if it helps or not, but I spent too many years as a stay-at-home mom, so I always picture, never mind. Okay, so how many ways can a committee, so committees will be combinations of 4 men and 5 women, be chosen from a group of 7 men and 7 women. We've got 7 men and 7 women, so 14 people altogether. We're picking 9 out of them, but it's not like 14 combination 9 because we've got these different subsets. Does it make sense when I see that word and I start thinking of my counting principle? And I think I want men and, that's an M by the way, women. And so how many ways can I choose the men? We said committee is a combination. How many men are there to choose from?
4.
What's the total number of men we have? Read to the end of the question.
Oh, sorry.
We're picking from 7 and we want 4.
Yes.
And how about women? We're picking from 7 women and we want 5. And
Yeah.
that word "and" in between, remember the counting principle says if I want men and women, it's the number of men times the number of women. So 7 combination 4 is 765 over 321, 35. 7 combination 5 is 21. And so we'll multiply those then and get 735. And does everybody see for this problem the need to do 2 separate combinations, one for the men and one for the women? Is that one all right? I'm not hearing any answers. Can I go that this is okay, or do you need me to stay on this page for a minute?
I don't know. I'm sorry.
Don't apologize.
I don't have a calculator yet. I have to go to the store today and get a calculator. So I'm trying to follow along as like best as I
Okay,
can.
if you don't have a calculator where I have that 7 combinations, set 4, the 4 tells me the denominator is 4 times 3 times 2 times 1. With combinations, I have as many factors in the numerator as I do in the denominator. And so then I can cancel out the 4s, the 3 and the 2 come out, cancel out the 6, and that gives me 35.
Why would we cancel out the 3, the 2, and the 6?
Because if you don't want to cancel them out, you don't have to. But if I take, if I would have left that as 7 times 6 times 5 over 3 times 2 times 1, that's 7 times 30 is 210 divided by 6. And I'd have to do that long division to get 65. I'm sorry, 35. I find it easier if I can think 3 times 2 is 6, so I can divide out the 6 before I multiply instead of after.
Okay.
Okay. So it's not fun doing them by hand, but they're doable. You just have to do a lot of multiplication and division. So, yeah. So a calculator is probably a good thing to have.
What kind of calculator do you have? Like, what should I get?
Best is the TI-30X. It's the Texas Instruments one. It's solar, so you don't have to worry about a battery, and it's got 2 lines of display. Depending on where you go, if you go to the bookstore, it might be over $20. If you go to some place like
Office Max?
Office Max, it should, depending on if they have like a school sale or not. I've gotten them for as low as $6. I wouldn't pay, at most I would pay $14, $15 for it.
Okay.
Okay?
Because that's what I'm doing like immediately.
Okay. All right. Now, I'm going to clear this and turn the page. And let's look at some of those problems on the next page. Oh, I got to turn my finger back into a mouse. Did I hit that too often? Did I turn 2 pages? So let's look at question number 44. And for these, I just want to decide, would it be a permutation or combination? And set it up. 44 says 50 people purchase raffle tickets. 3 winning tickets are selected at random. First prize is 1,000. Second prize is 500. Third prize is 100. How many different ways can the prizes be awarded?
Is this a permutation?
Tell me why.
Because order matters.
Order
Because
matters.
if
Beautiful.
like first place, you get more money than you would third place.
Right. Now, how many do we have to pick from?
Places or people?
People, 50, and we're going to pick 3 winners. Does that make sense for the setup of that one?
I think so.
Now I want to skip down to 46. 46 says 50 people purchase raffle tickets. 3 winning tickets are selected at random. Each prize is $500. In how many different ways can the prizes be awarded? With this one, if all 3 prizes are the same, does order make a difference to you?
No.
No. So is everybody all right? This one would be a combination. And it would be 50 combination 3. Let's look at 50. 55 says Baskin Robbins offers 31 different flavors of ice cream. One of its items is a bowl consisting of 3 scoops of ice cream, each a different flavor. How many such bowls are possible? So you're ordering a bowl of ice cream and you pick your 3 favorite flavors. Does it make a difference to you which order the scoops were put in the bowl?
No.
No. So is it a permutation or a combination?
Combination?
And we have 31 to pick from, and we're picking 3. Let's look at,
Wait, so it'd be 31 combination?
yes, it would be 31 combination 3, and I think I said 31 and wrote 3, I'm sorry.
It's okay.
Let's look at 52. 52 says there are 6 employees in a stockroom in an appliance retail store. The manager will choose 3 of them to deliver a refrigerator. How many 3-person groups are possible? When you're putting together that group of 3 people, does it make a difference whose name was said first, whose name was said second, whose name was said third? Or no? So that would be a combination where you've got 6 to pick from and we pick 3.
Okay.
Those ones all right.
Yeah, this is helping a little bit.
I want to clear this and scroll down on the page a little bit if it lets me. Need my mouse and not my pen. I hate it when it doesn't let me move down on the page. Does anybody have a secret how to get these stupid sliders to work when they don't want to work for you? I'm sitting here with my
Arrow pad thing on your keyboard. Like sometimes if I arrow down, my page will move.
all right. Oh, this damn keyboard has arrows right and left, but not down.
Oh.
Yeah. Well, I'm going to just make them a little bit smaller so that I can fit more on the page. Ooh, too small. Okay, so I want to look now down at, I'm sorry, it's a little small, but let's say I want to look at 53. It says you have 3 dress shirts, 2 ties, and 2 jackets. You need to select a dress shirt, a tie, and a jacket for work today. How many outcomes are possible? How would you figure this one out?
I think that's just fundamental counting. Right?
Is everybody right? Beautiful. Thank you. I'm very excited with how quickly you came up with that. This is just a counting principle. We've got 3 shirts and 2 ties. That's a 2, by the way, and 2 jackets. And so for this one, we're just going to multiply, and we get 12 different outfits. Let's look at 55. A chef has 5 brands of hot sauce. 3 brands will be chosen to mix into a gumbo. How many outcomes are possible? When you're
Is this also a counting one?
I'm not sure. What do you guys think?
It's actually a combination.
Why is it a combination?
Well, the order doesn't matter, but we have a few distinct items.
Yeah, order doesn't matter, and we're picking 3 out of 5. So this would be 5 combination 3. Let's look. let's look at, I'm not seeing the examples that I want. Just like this one. Say 47 says, how many different four-letter passwords can be formed from the letters A, B, C, D, E, F, and G if no repetition of letters are allowed? So how many letters are there? 1, 2, 3, 4, 5, 6, 7. Of those 7 letters, how many are we choosing?
4.
4. And now when you put your password in, does the order of the letters matter?
Yes.
Yeah.
So permutation.
That one's a permutation. Okay. So, little bit better the difference between those permutations and combinations. I'm looking for one more. And to get to that last one, of course, it's like way down on the bottom of the page. Is everybody all right if I clear what I've written so far?
Yeah.
Okay. Damn it. Okay. I'm going to shrink it just a tiny bit. I'm going to look way, way, way down here. And it says there are 4 Democrats and 5 Republicans on the county commission. From among their group, they want to choose a committee of 2 Dems and 2 Republicans to examine a proposal to purchase land. So altogether, there are 4 Dems and there are 5 Republicans. And we need for a committee 2 Dems and 2 Republicans. If it's a committee,
Combination.
combination. Now for this one, am I going to need 1 combination or 2 combinations?
2.
2. We need a combination for the Dems. 4, choose 2. We need a combination for the Republicans. 5, choose 2. Once I figure out my 2 combinations, what do I have to do with the 2 answers?
You multiply them, right?
Multiply them because the counting principle says it loosely when I see that word and, if I've got 2 separate things occurring, to find the way in which they can occur one and the other, I multiply. So 4 combination 2, let's see, that's 4 times 3 over 2 times 1, which is 6. 5 combination 2 is 10, and so that gives me 60. Okay.
So anytime we see and, we should multiply. Is that safe to say or no?
Not every time, but most times. Loosely, we're going to find when we're looking at probability type problems, the word and usually means multiply, but you have to be careful. A little bit later on, when we start looking at the definition of probability, we're going to start looking at things like cards. And if I say, what are the chances that I get a queen and a heart? I'm not going to multiply queen by hearts. I'm going to say a queen and a heart, that's the queen of hearts. And it's the overlap of the 2. So sometimes we look at that word and as meaning intersection.
Okay.
As opposed to, I want to know how many ways I can get a Democrat and a Republican. Well, those are 2 separate events. And so I'm going to find the 2 separate and multiply them. Okay? All right, looking at my itty bitty watch, we have 4 minutes left, and what I wanted to start next takes a hell of a lot longer than 4 minutes. So, shall we stop here?
Could you do one more of the example real quick with the one that you gotta put in order?
Okay. Let's look at, oh, I hate this question, but we'll look at it. Actually, oh, wrong way.
You can do over one of the first ones that you did.
Yeah,
I just want to see it again.
I want to look over here at 45. 45 says from a club of 20 people, how many ways can a group of 3 members be selected to attend a conference? In that one, does order matter?
No.
No. So that would be 20 combination 3. I want to change the wording of that question a little bit.
Yeah,
And
but I wanted to see the one that you gotta put in order, like order matter.
I'm going to alter this question.
Oh, okay. All right.
So instead, from a club of 20 people, oh, I'm erasing the wrong words. I'm crossing out the wrong words. In how many ways can, let's change that, instead of a group of 3 members be selected to attend a conference, let's change that into how many ways can they elect 3 officers? And the officers would be president, vice president, and secretary.
Oh, got it.
And so now if I'm electing 3 officers, if you're one of those 3 people, does order matter? Does it matter to you which office you hold?
Yes.
Yeah.
Yes. And so do you see, if I change it to 3 officers, then it's going to be a permutation. And it would be 20P3. And there's no words in there specifically says, because order matters. But your life experience tells you when you're holding an election, the order matters, right?
That would be 6,840, right?
I have absolutely no idea. It's 20 times 19 times 18. So let me, oh my God, I just made up the problem and you want me to be able to look at it. No, a little harsh, don't you think? Actually, no, 20P3, I got 6,840. Is that what you said?
Yeah, that's what I said.
Okay, I'm sorry. My memory held that different because I was overwhelmed with the thought of like trying to just look at it and see the answer. That, dissecting that problem and rewording it a little bit.
Yeah, it helps. It helps. Yeah.
Okay, so running a race, order matters. Holding an election, order matters. You know, if it's a raffle and the prizes are different, order matters. If it's a raffle and the prizes are all the same, order does not matter. Instead of an election, if it's a committee or a group, order does not matter. Yeah, that helps so?
Yeah, it did.
When you play cards, usually the order of the cards does not matter because you just pick up your hands and you look at your cards. When you look at your cards, you don't care which came first, second, or third. You just care which ones you got. So,
Yeah.
okay.
All right.
All right. Anything else for anybody else? I'm going to stop sharing. I apologize that I was technologically challenged when it came to moving the pages in the book. I promise